There's something strange in the solar neighborhood, and NASA's Perseverance Rover captures the eerie details about those odd sounds on Mars. Since the Jet Propulsion Laboratory, managed by NASA, built and manages operations of the Perseverance Rover, you'll get the inside information directly from the source. After you've learned about the source of the sounds and its indications for future Mars colonization, stay tuned in to see the latest alien eclipse captured by the Perseverance just recently. So let's not keep you in suspense. An international team of scientists, with the help of the Perseverance Rover, has listened carefully to sounds on Mars. Although there's virtually no sound on the vacuum-like atmosphere of Mars, a large data dump of information about Mars did come from the rover's mechanical whine and clicks in light Martian winds, the whir of rotors on Ingenuity, the Mars helicopter, and the crackling strike of a rock-zapping laser. When analyzing these subtle sounds that might seem insignificant, scientists have been able to publish a new study pointing out how and why the speed of sound is slower on the red planet compared to Earth, and their understanding of why there's an unreal prevalent silence. According to Sylvester Maurice, astrophysicist at the University of Toulouse in France and lead author of the study, the international team of scientists has performed the first analysis of acoustics on the red planet. Their new study reveals how fast sound travels through the extremely thin, mostly carbon dioxide atmosphere, how Mars might sound to human ears, and how scientists can use audio recordings to probe subtle air pressure changes on other worlds. Moreover, the scientists have honed their skill to amazement levels, as they can actually gauge the health of the rover simply by sound. The study was published in the journal Nature on the 1st of April, but it's no April Fool's Day prank. According to the study, most of the sounds were recorded using the microphone of Perseverance's SuperCam, which is mounted on the head of the rover's mast. The study also refers to sounds recorded by another microphone mounted on the chassis of the rover. This second microphone recently recorded the puffs and pings of the rover's gaseous dust removal tool, or GDRT, which blows shavings off rocks that the rover has scraped in order to examine. Sylvester Maurice was quoted saying, "It's a new sense of investigation we've never used before on Mars. I expect many discoveries to come, using the atmosphere as a source of sound and the medium of propagation. Due to the remarkable results of the recordings, where the speed of sound is slower than on Earth and varies with pitch or frequency, mankind now has a new understanding of the strange characteristics of the alien atmosphere. Here on our planet, sounds typically travel at 767 miles per hour. That's an astounding 343 meters per second. But on Mars, low-pitched sounds travel at about 537 miles per hour, which is only 240 meters per second. As for higher-pitched sounds, they move at 559 miles per hour, or 250 meters per second. Another effect of this thin alien atmosphere is that sounds only carry a short distance, and higher-pitched tones carry hardly at all. On Earth, sound might drop off after about 213 feet, or 65 meters. Blast off to Mars, and notice that sound falters at just 26 feet, which is only 8 meters. As for high-pitched sounds, they're basically non-existent at 8 meters. The study shows that the variable sound speeds on the red planet are an effect of the thin, cold carbon dioxide atmosphere. The recordings from SuperCam's microphone also reveal previously unobserved pressure variations produced by turbulence in the Martian atmosphere, as its energy changes at tiny scales. Martian wind gusts at very short timescales also were measured for the first time. But a lot of this information didn't come as a major shock to scientists. Actually, prior to the mission, scientists proposed that the Mars atmosphere would surely influence sound speed. Now the phenomenon has been recorded, observed, and confirmed. According to Sylvester Maurice, one of the most striking features of the sound recordings is the silence that prevails on Mars. That too is a consequence of Mars having such a thin atmosphere. At some point, we thought the microphone was broken. It was so quiet, Maurice espoused. Then his colleague, Baptiste Chide, of Los Alamos National Laboratory in New Mexico, a co-author of the study, chimed in and explained, "Mars is very quiet because of low atmospheric pressure, but the pressure changes with the seasons on Mars. That indicates that in the Martian autumn months, Mars is expected to get noisier and provide even more insights into its otherworldly air and weather." Chide also noted, "We are entering a high-pressure season. Maybe the acoustic environment on Mars will be less quiet than it was when we landed." The studious acoustic team was also able to observe the SuperCam microphone picked up from the spinning double rotors of Ingenuity, the Mars helicopter, the rover's traveling companion and aerial scout that will forever hold the title as the first powered flight on another planet. Referring to the standard acoustic measure of vibrations per second and the rotation rate for both rotors, Maurice noticed that the the rotors spin at 2,500 revolutions per minute, and they produce a distinctive, low-pitched sound at 84 Hz. On the other hand, when SuperCam's laser, which vaporizes bits of rock from a distance to study their composition, strikes a target, it makes sparks that create a high-pitched noise above 2 kHz. As previously mentioned, studying sounds recorded by the rover's microphones not only reveals details about the red planet's atmosphere, but it also helps scientists and engineers assess the health and operation of the rover's many systems. It's similar to noticing menacing noises coming from your automobile, but on a more complex scale. Meanwhile, the key instrument in the study, SuperCam's microphone, continues to exceed expectations. David Mimon, professor at Institut Supérieur de l'Aéronautique et de l'Espace, known as ISAE Supero, and lead of the team that developed the microphone experiment, was quoted saying, "The microphone is now used several times a day and performs extremely well. Its overall performance is better than what we had modeled and even tested in a Mars-like environment on Earth. We could even record the humming of the Mars helicopter at long distance." The main objective for Perseverance's mission to land on Mars is actually for astrobiology. NASA still finds it essential to find signs of ancient microbial life, if not more developed life forms. Next, the rover's goal is to characterize the planet's geology and past climate, pave the way for human exploration of the red planet, and be the first mission to collect and cache Martian rock and regolith, which is the scientific term for broken rock and dust. As for actually bringing the Mars samples to Earth for further in-depth analysis, subsequent NASA missions, in cooperation with ESA, European Space Agency, will send spacecraft to Mars to collect these sealed samples from the surface and bring them to our home planet. The Mars 2020 Perseverance mission is part of NASA's Moon to Mars exploration approach, which includes Artemis missions to the Moon that will help prepare for human exploration and colonization of the Moon and the Red Planet. NASA's Perseverance Rover has footage of a solar eclipse on Mars. While studying the orbits of Mars' 2 moons, the Perseverance was able to record video of Phobos, the red planet's potato-shaped moon. These observations will help scientists better understand the moon's orbit and how its gravity pulls on the Martian surface, which is ultimately shaping the red planet's crust and mantle. So, the applications of this knowledge could be literally as deep as Mars' core. Thanks to the Perseverance's next-generation Mastcam Z camera, the footage was able to be captured. It all occurred on the 2nd of April, the 397th Martian day, when the eclipse lasted a little over 40 seconds. And if you're thinking that 40 seconds is the shortest eclipse that you've ever heard of, keep in mind that Phobos is about 157 times smaller than Earth's lunar satellite. Equally shocking, Mars's other moon, Deimos, is even smaller. While these images are brand new for the Perseverance, it's nothing new for NASA capturing solar eclipses on Mars. Back in 2004, the twin NASA rovers Spirit and Opportunity took the first time-lapse photos of Phobos during a solar eclipse. Then, the Curiosity followed the trend and lived up to its name by also capturing a Mars solar eclipse with its Mastcam camera system. But let's not take the Perseverance solar eclipse footage for granted. As it virtually just landed on the surface of Mars in February of 2021, it has provided the most zoomed-in video of a Phobos solar eclipse so far. Plus, it provides the highest frame rate ever. So, to make a long story short, Perseverance has the better tech thanks to its next-generation Mastcam Z camera system, which is a zoomable upgrade from Curiosity's Mastcam. Thanks to the various Mars rovers, space discovery increases with wonder every day, double-fold. Were you shocked to hear that sound is hardly heard on Mars? And what do you think about Mars's tiny moons, and especially the potato-shaped moon, Phobos? Comment down below. Your opinions and comments are truly valued, just like knowledge itself. Smack that like button and subscribe to Space Infinity.